Around from where we stopped in the last class, and we were treating the mock past questions, and we stopped at number 3. Somebody will be reading the questions while I'm answering them. This is the first question.
Number 3.
Number 3. Number 4. Number 4. You start from number 4. Then please speak out.
Okay. Number 4 question. Show by means of balanced chemical equations only the industrial preparation of tetrahydrosulfate 6 acid.
Okay. Show by means of chemical equations only the industrial preparation of tetrahydrosulfate 6 acid. The chemical formula is H2SO4. Everybody knows this. And the name given to the industrial preparation is called contact process. It is by contact process. The question requires us to just enumerate the chemical equations. The first of the process is that a reaction between oxygen and sulfur is going to take place to give us sulfur 4 oxide as the first step in the process. This sulfur 4 oxide is going to be further oxidized to become sulfur 6 oxide. Now, sulfur 4 oxide plus oxygen to become sulfur 6 oxide. This is oxidation. And at this step, now, another reaction will come in at this step in which sulfur 6 oxide will react with H2SO4. Sulfur 6 oxide plus H2SO4, it will give us a viscous liquid known as oleum. Oleum chemically is H2S2O7. And finally, this oleum is going to be diluted. This is oleum. This is sulfur 4 oxide. This is sulfur 6 oxide. Then dilution of the oleum will give us tetrahydrosulfate 6 acid. Dilution, addition of water, so that we have 2 molecules of tetrahydrosulfate 6 acid. These are the steps involved in contact process, the industrial manufacture of H2SO4 tetrahydrosulfate 6 acid. What are the conditions necessary for these reactions to take place? Now, this one plus this one will give us sulfur 6 oxide, but this one is going to be dried because there is going to be an element of moisture or water when this one is formed. And one thing you need to know is that the reaction is exothermic. Exothermic, meaning that heat is liberated. Heat is given out from the reaction. You can see, and you know how to denote exothermic reaction. There is a negative enthalpy. The enthalpy is negative for this, meaning that the reaction is giving out heat to the surrounding. Now, I was saying this one is going to be dried. What is the drying agent for this? The drying agent is H2SO4 itself. Dries this gas before it is further oxidized to give us sulfur 6 oxide. One thing I want you to note in these 2 reactions is that I want to change this. You know, the normal way of showing reactants are transforming to form product is to use this arrow. But these 2 reactions are reversible reactions. You indicate that with reversible arrows. This one also is a reversible reaction. Now, So I hope you are following me, because we are going to dry this with H2SO4. Now, for this reaction to take place, we have some conditions that must be met. The temperature requirement is between 450 to 500 degrees Celsius for this one to take place. And also high pressure is also required. As well, a catalyst is needed for this process, for this step to occur. The catalyst is vanadium 5 oxide. Vanadium 5 oxide. One thing I want to point out about this reaction is that this one is called homogeneous catalysis, in the sense that the state of the catalyst is the same as the state of the reactant and the product. All these are gases. Sulfur oxide is a gas, oxygen is a gas, sulfur 6 oxide is a gas, while this vanadium 5 oxide also initial state. This is homogeneous catalysis. Then sulfur 6 oxide will proceed. H2SO4 concentrated, mind it, concentrated H2SO4 will be added to this, and this one becomes oleum. If you want to check, let us ensure the equation is balanced. If you look at this, we have 2 sulfur here. You can see S2. Hydrogen, we have 2 hydrogen atoms here. You can see 2. Then oxygen, 3 plus 4 to give us 7. This is oleum, a viscous liquid. This is a liquid. While the oleum will now be diluted to give you tetraoxosulfate 6 acid. This acid is obtained 98% pure. It is 98% pure. This is the concentration of the H2SO4 obtained by contact process. Now, I want to move to the next question.
The next question: distinguish between dehydration and drying.
Thank you. Distinction or difference between dehydration and drying. Dehydration and drying. Now, dehydration involves removal of water from a substance, in which the chemical nature of that substance changes at the end of the process. Please get it right. Removal of water from a substance, which will eventually change the chemical nature of that substance. For example, we have a derivation of ethanol, C2H5OH. Now, we said removal of water. Let's minus water. Different class of, can you see? It has changed its chemical nature. It has changed the functional group. As a result, it has changed the chemical nature. An example can also be found in the derivation of sugar, sucrose. Sucrose is C12H22O11. When you remove water from this, removal of water, it will give us carbon, only carbon. We are going to have 12 carbon, meaning that 11 molecules of water are removed from this. The chemical nature has changed. This is a sugar. This is a mere carbon. This is charcoal, a coal. Can you get the difference between the two? While drying, the chemical nature remains the same. Ammonia remains as ammonia. It will not change. Okay? Let's look at some drying. That is drying, removing water. And the dehydration and drying, they can take place when you vary the condition. When you increase the temperature, you are drying, and you can use some chemical agents also to dry. Can we move to the next question?
The next question: explain why concentrated H2SO4 cannot be used to dry ammonia.
Yes, Explain why conc H2SO4 cannot be used in drying ammonia. Now, the drying agents are deliquescent and hygroscopic. What I mean, the two substances absorb moisture or water from any substance which they react with. While deliquescent will form solution when they absorb water. You know, I talked about dilution the other time. When you add water to reduce the strength or concentration of a chemical or substance. Now, the deliquescent substances, they absorb moisture and they dissolve in the moisture to form solution. While hygroscopic, they only absorb moisture